Hi everyone, welcome back to my channel. You are watching Education to All. Today we are going to discuss differential equations. So we learn differential equation very clearly with the basic definitions. What is meant by differential equation? The definition attached here, please observe carefully. The differential equation is an equation that contains one or more functions with its derivatives. What it means? Let me write an example. Suppose if dy by dx plus e power x is equal to 0. So dy by dx is called the first derivative and e power x is another function which is equal to 0. We'll write few more examples. So d square y divided by dx plus suppose y square is equal to 0. We can write one more example. dy by dx plus sin x is equal to 0. So these all are differential equations. After we are going to write dy by dx which also represented as y1 or dy by dx which is also write y dash. If we are doing the differentiation two times, d square y by dx square we'll write as y double dash, otherwise y2 will represent. Definition number 2. Order. What is meant by order? The order of differential equation is the order of highest order derivative present in the equation. Let me write an example. If suppose dy by dx plus y equal to 0. In this we are differentiating one time. So then I can say order is equal to 1. Second time, which means d square y by dx square suppose plus sin x which is equal to 0, which means we are derivating two times. So therefore order is equal to 2 in this one. Let me write one more example. D cube y divided by dx cube plus x square into d square y divided by dx plus some y is equal to 0. In this we need to identify the order. The order is here 2 times and the order is here 3 times. So which is having highest order we have to consider. So therefore order is equal to 3. So this is how the definition of order we have to understand. The next one more definition is that degree. What is meant by degree? So attaching the definition here. The next definition is degree. What is meant by degree? Observe carefully. The degree of the differential equation is the power of the highest order derivative where the original equation is represented in the form of polynomial equation in derivatives such as y dash, y double dash, y triple dash, which means first order derivative, second order derivative, third order derivative. Let me write an example to understand very easily. So how to find a degree? Let us imagine degree is equal to finding in a particular particular differential equation. So let me write a differential equation first. D cube y by dx cube plus 2 into d square y by dx square whole power 2 minus dy by dx plus y is equal to 0. Check whether it's a differential equation or not. Definitely it's a differential equation. Then what is it? Degree. So degree means the highest order. First to identify which is having highest order. So it is differentiate 3 times, it is differentiate 2 times, it is differentiate 1 time, and it's a function. So I can surely say that order is equal to 3. Highest order is 3. Then what is degree? The order highest power having which exponent, that is called an order, which means here then exponent of the third order is 1. Then I can say the degree is equal to 1. Are you clear, students? Please listen carefully. Which order is highest is there? Their exponent. Here, identify carefully. Their exponent is nothing. Nothing means 1. I can say that it's degree 1. So, one more example we'll take. For example, so dy by dx whole square plus dy by dx minus sine square y, which is equal to 0. In this differential equation, the order is first order only, one time differentiation, and here also one time differentiation. But it having exponent is 1, here exponent is 2. So I can say order of the differential equation is 1, but what about degree? Where degree is equal to 2. So one more example we'll take. Let me see the one small example. Therefore, dy by dx plus sine of dy by dx, which is equal to 0. Can I say it's a differential equation? Absolutely true. It's a differential equation. Then what about its order? Here one time differentiation. Here also one time differentiation. So I can say that order is equal to 1. Then what about its degree? So everyone say its degree highest power is 1. So I can say 1. No, that is wrong. Why? It's a differential equation. It's not in a proper way. For these type of differential equation, degree cannot be found. Why? Because let me take an example to get better understanding. Let us take f of x is equal to sine y. If differentiating with respect to x, f dash of x is equal to sine y differentiation cos y, and y differentiation is dy by dx. So when I differentiate the any trigonometric function, so we'll get dy by dx is outside, but it is never come dy by dx inside. For these type of differential equations, degree cannot find or not defined. And different type of differential equations are there. First one, variable separable differential equation, homogeneous equation, non-homogeneous equation, linear equations, Bernoulli's equations. We'll try to solve each and every method with one example. Please listen carefully. So method 1, variable separable method. Let me take an example. Let dy by dx, which is equal to 1 by y square divided by 1 plus x square. So variable separable method means we have to send the all x variables to one side, all y variables to the one side. Sending the opposite side x, so we get 1 by 1 plus y square into dy, which is equal to 1 by 1 plus x square into dx. Now we need to do integrating on the both the sides. Apply the integration. So we have a formula integral 1 by 1 plus y square dy. So I can write tan inverse of y, which is equal to again integral 1 by 1 plus x square dx. So tan inverse of x plus constant. So therefore this is the required solution of a differential equation. Let me write one more example. Dy by dx plus y is equal to 1. So convert into a variable separable method. I'll take the y value to opposite side. So we get dy by dx is equal to 1 minus y. We have only single variable y. So y variable send opposite side, x dx send opposite side. 1 by 1 minus y into dy, which is equal to dx. So now integrating on the both the sides. So 1 by 1 minus y, I can write the log of 1 minus y, but it having a negative, so negative log x, which is equal to integral dx. Integral dx means I'll get the x and plus I can take the constant is log c. So writing the log c. This log c opposite side. So I'm taking the log c is opposite side minus log of 1 minus y minus log c, which is equal to x. So anyhow both having negatives, I'm taking negative outside, so we get log of 1 minus y plus log c, which is equal to x. By solving this condition, so log a plus log b, we have a condition, so log of ab, then minus outside logarithm of 1 minus y is multiplied to c, which is equal to x. This negative I'm giving to the x value, so therefore log of 1 minus y into c, which is equal to minus x. To remove the logarithm, I'll take anti-logarithm, so which means 1 minus y into c. If I am removing the logarithm on left hand side, I have to give exponent to the opposite side. So I'm writing 1 minus y is equal to e power minus x divided by constant. Finally, we required y. So send opposite sides. So we get y is equal to 1 minus e power minus x by constant. Okay. Next method is homogeneous equations. What is meant by homogeneous differential equation? If any differential equation, we cannot separate the variables, and that type of equations are called as homogeneous equations. So let me see an example. F of x comma y, which is equal to y square plus 2xy, and xy having both combinedly in a same single term, we cannot separate, and y square is added. So these type of differential equations are called homogeneous differential equations. Then how to solve these type of differential equations? Then what is a working rule? For example, let me take an example. A dy by dx, which is equal to x plus y divided by x. Then by observing this, we cannot separate the variables. Either this is in the format, or sometimes dx divided by dy, which is equal to the same way x plus y divided by y, imagine. So these are the two differential equations which are in a form of homogeneous. How to solve this differential equation? So let me take, if any function in the form of dy by dx, we consider y is equal to vx. If any differential equation in the form of dx by dy, we consider x is equal to vy, and differentiate with respect to x on both the sides. So dy by dx, which is equal to, this is uv formula, v plus x into dv by dx. For this, we'll get differentiate with respect to y, dx by dy, which is equal to v plus y into dv by dy. So there, wherever we observe the dy by dx, just replace this function v plus x dv by dx. So by observing this question, we are going to solve. We have dy by dx, which is equal to x plus y divided by x, and writing v plus x into dv by dx, which is equal to x plus, we consider y is equal to vx, so then replacing vx in a numerator divided by x. Therefore in a numerator, identify x can be taken out, so what is there? 1 plus v divided by x. In left hand side, v plus x into dv by dx. So the numerator and denominator x cancel. So what is still pending? We got v plus x into dv by dx, which is equal to 1 plus v. We got in both the sides v cancellation. Still what was pending? Write the remaining x into dv by dx, which is equal to 1. Now we can separate the variables by cross multiplication. We have dv is equal to 1 by x dx. Here after the same procedure like variable separable method, we can use the variable separable method. So integrating the both the sides, we got integral dv. Integral dv means v, which is equal to 1 by x dx, which means log x and plus c. where we have v means from consideration y is equal to vx. So from this I'll solve v is equal to, can I write y by x? So therefore write the y is equal to y by x, which is equal to log x plus c. Therefore I can say y is equal to x log x plus c into x. Therefore required differential equation solution, y is equal to x log x plus cx. Next type, non-homogeneous equations. How the non-homogeneous equation can be solved? Let me take an example. dy by dx, which is equal to x minus 2y plus 3 divided by 2x plus y minus 5. Cross multiply the both, so we get 2x plus y minus 5 into dy, which is equal to x minus 2y plus 3 into dx. So now integrating separately with each and every term, integral 2x dy plus integral y dy minus integral 5 dy, which is equal to integral x dx minus integral 2y dx plus integral 3 dx. Here we have to be very careful. Here integral 2x dy minus 2y dx. So write this separately by sending left hand side. I'm taking, send this y towards to the left hand side. So taking 2 is outside, integral x dy and minus becomes plus integral y dx, writing together, and remaining integration integral y dy, which can be written as y square by 2 minus 5 constant into y and constant 1, which is equal to integral x dx. So we can write x square by 2 and plus 3 is a constant, 3 outside into x plus constant 2. And we have a separate condition, integral x dy plus y dx together is xy. So 2 into xy plus y square by 2 minus 5y plus constant 1, which is equal to x square by 2 plus 3x plus constant 2. To simplify this constant by taking LCMs, so in left hand side 2 is an LCM, 4xy plus y square minus 10y plus 2 into constant 1, which is equal to, again 2 is an LCM in right hand side, so we get x square plus 6x plus 2 into constant 2. In both the sides 2 cancel and send all to the opposite side. Therefore square minus y square plus 6x plus 10y minus 4xy, 2 into constant 2 minus 2 into constant 1, which is equal to 0. And these both together is a constant, so a constant, a difference also constant only. Therefore the final answer required is x square minus y square plus 6x plus 10y minus 4xy plus constant is equal to 0. Therefore this is our required differential equation solution.